about the interface that it offers. It's not talking anything about the details. So an object can have many types. Yeah, can satisfy many interfaces. Don't jumble up classes and types, though inheritance always entices us to do that. A class is an intentional thing, a type is an extensional thing. All right, now, smells. Now I'm going to talk about what a smell is. I sort of hinted at it while we were talking about it with Richard. The idea is, if we're doing this incremental thing, if we're not doing our big design up front, but we're just doing a design and then we're changing it, and design and we're changing it, and remember our strategy is you do the design, you make it work. When it passes all the tests, you refactor it to make it beautiful. Then you're finished. Then you have to add a new feature, make that new feature work by passing all the tests, then refactor to make it beautiful. And you keep doing that. That's our iterative step. So we make it work, then we refactor, make it work and refactor. And the refactoring gets us all ready to do the next step, makes everything nice. So the first part is adding the new functionality. The second part is not changing the functionality, but it's changing the code. So this is an incremental way of developing your code. How do we know our code's going to converge on something really good? How, the evolution thing. How do you know by just making small incremental changes to single-celled animals? How could we ever evolve an eye? Is there like a path of small incremental changes that'll lead us towards a globally good outcome by making small local decisions? Well, one of the things that we have to sort of guide us in this path, we don't want to do it by random. We can't write 1 million programs and randomly select which is the best performing. We're only going to get it right one. So what guides us in working out how to change our code when we refactor is there's certain things that we call smells. And smells are things that normally indicate something bad's happened. Now, the smells aren't in and of themselves bad. They're just often associated with bad things. So when you've got a smell in your code, you look at it suspiciously. And if you've got a good reason, you leave it in. But if you don't have a good reason, you get rid of it. That's what a smell is. So let's start thinking of what smells are. I thought what I'd do is I'd read you some of the things from the GO4 book where they're talking about this notion of how to slowly converge on a good design, the attributes we want and the attributes we don't want. And then I'm going to ask you to think of specific things you could see in code that you would regard as a smell. So the GO4 book is the design pattern book, which is I've already talked about and everyone should get. And someone did say I was reading someone's lecture notes or something and they said, it was a lecture that I was talking about the observer pattern, and when I got to the bit where I read out of the book for a long time, they said, read out of the book for a long time, and didn't actually say any of the things I said, and said, sort of bitterly, might as well have bought the book. Yes! Yes! Buy the book! Buy the book! Absolutely. And I read out of the book because, it was my little joke, because, in a sense, I think the ideas in the book are really good, and if I explain observer pattern to you, you might think, oh yeah, I get observer pattern, I'm a master of observer pattern, I don't need to get that book because now I understand observer pattern. And I wanted to show you the level of detail that went into talking about observer pattern and some of the really cool ideas it had about the observer pattern, which wouldn't just occur to you normally, to show you the depth of courage to excite you to want to read the book. Why did I read out of the book rather than paraphrasing it and writing it up as my own lecture notes? What was I trying to do? Not small steps. I was trying to do... insist the book's worth buying. Yeah. That was my objective. But I was trying to do... No, reuse. There's no point in rewriting the words in the book. The book says it perfectly. So let's delegate to the book. Yeah. Cool. So that's a good book. Now, this is one of my 3 favourite books at the moment. My next favourite book is Martin Fowler's book, which I just love so much. It makes me excited every time I read it. I just sit there giggling and laughing to my wife saying, oh, he's got a good idea here. I'd never have thought of that. And my last and most probably favourite of all the books, possibly because it's the one I got most recently, is Refactoring to Patterns by Josh, and I can never say his name, I don't know how to say it, Karyevsky, something like that. Refactoring to Patterns. This is an awesome book, and it links together the design pattern books and Martin Fowler's refactoring book, and it talks about how you can make changes to your code to improve the code all the time moving towards a pattern. Because yeah, patterns are a solution to a problem, but when you're refactoring, you don't want to just grab a solution and mindlessly use it. That's what everyone hates about patterns. People that just use them inappropriately. You want to always make incremental changes. And this book says, here's how you can make incremental changes inspired by this book. And it is, when I read this, it just makes my toes curl. There's so many good ideas in it. It makes me so pleased to be a programmer. What an interesting and intellectual discipline we have, because there's all these beautiful things you can do. Okay. So let's just start with the GO4 book. Now, they had a couple of tips. Where are they? I thought I had them here. I thought I wrote them all in. Yeah, here the GO4 smell. Okay. And the last thing I wanted to say is you could do this incremental process by moving towards good things. So you could have a list of good things you want to get, or you could have a list of bad things you want to move away from. And it turns out the good things tend to be so abstract that I think when you start programming, it's hard to spot what the good things are. I mean, someone explains what they are and it makes sense, but how do I literally change my code to get these good things to happen is a bit of a conceptual leap. But the bad things, the smells, are so easy to see in your code that often we do it by talking about smells. So there's both a good and a bad, a carrot and a stick way of slowly changing your design. Let's look at the Gang of Four. They talk about things in your code that might mean you can't meet your change objectives. Remember, our objectives are easy to change and correct after changing. Here are things you might find in code that will make the code not behave nicely when you change it, or make it brittle, or make it lots of work to change it. Here's a bad thing number one. Creating an object by specifying a class explicitly. So if you, when you need an object, say what class that object is, that's actually a bit of a smell. Yeah. Well, that's what we do. What's he talking about, man? That's Java. What's possibly bad about that? Have I written the answers there? Oh, yeah, I've already written the answers underneath each one. You commit to a particular implementation. When we code, when we write our programs, we always want to be focusing on the extensional things. You know, we went on and on about that in first year. So we want to be coding to interfaces, to abstractions. So literally, if I want something that is a machine, I want to create something that's a machine. But if you've made a particular machine like an M3, I don't want to create an M3 because maybe later on I want to create an M4. Or maybe later on I want to create an M3 but using your code rather than your code. Yeah? So instead, when I create things, I'd rather create things that are interface types, and then that lets me later on substitute other classes. And the nice thing about that is I can do that at runtime. So at runtime, I'm not bound to a particular thing. If you're locked into a particular thing at compile time, if you actually instantiate or create a particular class, then when you change that, you've actually got to rewrite all your code, and it'll make changes all over the place. Much nicer if you can do it so you don't have to change any code at all. It's just a bit of change of a runtime configuration. That necessarily, to be able to do that, your system must be loosely coupled. So that's a really cool thing. So we don't want to create objects by creating explicitly stating classes. Oh, okay. That's the only way we know of creating objects. So that looks like a problem straight away. Let's look at number two. Dependence on specific operations. So you don't want your code to depend on a particular way of doing something. So if you want to sort, you're in the middle of something and you want to sort something, you don't want to call a bubble sort method. What's the problem with calling a bubble sort method?
Bubble sort is a shit sorting algorithm.
Bubble sort. Well, who would ever want to sort shit? But if you did, I think touching it as little as possible would be best. I'd use spade sort, bucket sort. Yeah. Bubble sort sucks as a sorting method. But even if it didn't in one particular case, it might in another. So it's really nice later on to be able to change your implementation details, and not have to change your whole program. So rather than when I issue a request to another object to do something, rather than telling it exactly what I want to do, it'd be nice if I could somehow delegate that to the other object, and it works out how to solve it. And then later on I can substitute another object instead of you, and it can be done in a different way. So we don't want to be dependent on specific operations in our code if we possibly can. We'd like to be able to change the way a request gets satisfied. We don't want to be dependent on a particular hardware or software platform, because that's another form of coupling, and the hardware or software platform will change and then we're screwed. We'd like it to be able to change and everything still works, and we'd like to be able to port it to other ones and all sorts of things. We don't want to be dependent on the internals of an object, how the data representation works, the actual fields you've got in the object and so on, or even how they implement the methods in the object. We don't want to be locked into that, because if you're tightly coupled to someone else, if my object is somehow knowing what your object's doing inside, it knows how you're storing the data, or it knows how you're processing the data, or it knows how you're servicing a request, and I make use of that knowledge, we're tightly coupled. And now if you change, I have to change me as well. So our changes to the code is going to cascade through lots of classes, and it's a real pain. And once you start tightly coupling things like that, everything starts to magnetically draw together, and you get a big, enormous, monolithic lump And then any change is depressing and causes problems everywhere. And you want changes to be as isolated as possible. You don't want algorithmic dependencies. You'd like to be able to flip the algorithm around if you need to. You don't, yeah, before I sort of said that with bubble sort, but you might even want a different implementation of a bubble sort. You might want to keep bubble sort and change implementations. And then the bigger question is you might even want to change the sort of algorithm, the sort of sort algorithm. Yeah, yeah. You don't want tight coupling. I don't know why I've got refactoring as a smell. I think that's supposed to be a heading. Refactoring's good. Okay, so there are a list of things, general principles that you want to avoid, but that's not very detailed, is it? But it's general principles. Now what I'd like us to do is to list what you think are smells. So hopefully you're starting to do this now. When you do your reviews each week and you look at each other's code, are you starting to look and getting a sense for, oh, that's bad, and I want to look at that, and can you explain that part a bit more, because I'm a bit sus about that. What sort of things might we want to consider a smell? What things might alarm us or raise alarm bells when you see them in code? You can be as specific or as general as you want. Just shoot, hit me with ideas. Yep.
Magic numbers.
Magic numbers! Okay, these are like, this is code smells. That's right, that's like a stylistic code smell. Magic numbers. Magic's good, magic numbers, bad.
Just in general, code duplication.
Duplication. But literally code duplication, not just idea duplication, like cut and paste stuff. Paste duplication of code. Yes. Good. More. Things you look for in programs that make you alarmed. Yes.
Shortcuts.
Shortcuts. What's an example of a shortcut? What do you mean?
So if you've got a model
Yes.
in the real world that has multiple parts to it,
Yes.
and they've tried to sort of just only implement one or two of those parts and just have a few functions to represent the other ones, it can be a smell because
Yes.
you can't be sure that they're actually doing it correctly.
Now, can I say that's probably actually one of the famous code smells, I think, from the way you've said it, which is called oddball solution. Oddball solution is where you've got a class of things a range of things to deal with. You deal with most of them in one way, and a couple you deal with in some crazy other way. Maybe you're taking a shortcut or something like that. Maybe most of them are delegated to objects, but one or two you have little internal methods to deal with or something like that. You should do it. That's a standard smell. We expect to see everything dealt with in the same way. If someone does 9 things one way and the 10th thing gets handled in a different way, that's a smell. It's not necessarily bad, but normally it's an indication that something's bad. Normally it's an indication the design just happened rather than someone thought about it. And there's a patch there. Yep, that's a good one. Call that oddball. Yep, keep coming. Because I want you to think of them. Because if I tell you them, the ones that other people have thought of, and you just remember them, and then you just churn them through your code, you've turned into robots and automata, and you're reproducing the code that everyone else writes, and maybe that's not going to be good, or maybe it will be good, who knows? Yeah, I want you to actually think about it and come up with your ideas of what's a smell and what's not a smell.
Public attributes.
Public attributes, yeah, why are they a smell? Yeah, if you don't use a getter and people change it, they're tightly coupled to you.
And they can get changed by other functions acting on that.
And they can get changed by other functions, and invariants might get lost if there's certain invariants that have to be held. You're trusting the outside world to look after your data. Who can you trust? No one, except Ghostbusters. No, you can call them, but I don't think you can trust them. Yes?
Too many static.
Too many static. Or just static. Static's always a bit suspicious, isn't it? When someone's doing static, you think, are they in the land of C still? Yeah. Yes? If you can't test it, if you write things that are hard to test, that's a very bad design smell. Why? I think this is more high level than the other things. There are lots of reasons this is bad. Can someone think of why are you suspicious if someone's got code that's hard to test?
You know it's right.
It means they're probably not testing it. Yeah. Are they testing it? Yeah, good. What else?
It's not clear what's going on.
It's not clear. It's lost clarity. If it's hard to test, how can something be hard to test? Hard to test means you don't really know what right is, or it's really hard to articulate or measure, or possibly means that. And if you can't articulate or measure what right is, then it's probably hard to write code that is right. Yeah. Absolutely, yes.
I mean, it's hard to test. It's likely that it's not in sort of like small distinctions.
Yes, if it's hard to test, it's probably a big awful mess with bits and tentacles everywhere, and you can't actually get a plastic bag around it to test it, encapsulate it to test it. Yeah. What do we call that? Complex. Yeah. Good. All right, more smells. Smell. John, what's a smell that you hate seeing?
Executive.
Protected. Why do you hate saying protected?
Because, like, you reading knowledge private, either you make them public or you make them private.
Yeah, it's hard to know what role it's filling. It's giving special privileged access to your descendants. It's encouraging tight coupling between you and your descendants, and we hate tight coupling. It's suggesting someone's using something for code reuse rather than for interface reuse. Yeah. By the way, I think I said something wrong about protected that one of the tutors picked up, and I said, no, it can't possibly be like that, because I hardly ever program with protected, because I hate protected. And I said, protected means your children can read your data, but no one else can. But actually, that's not right. What does it really mean? Means, has anyone tested it? So you've probably been writing protected thinking you were protecting fields. Actually, you could have read them even when they were protected. Yeah, the package can also read them. So there's actually like a linear dependency between package, private, protected, and default in some order. There's actually an increasing amount of protection. So if you say something's protected, actually anything in the package can get it, plus any descendants in any package can get it. Now, that's even more insane than the one I thought. Yep. Okay. Protected, more smells. Yeah, Rupert. What's that? Copy paste, yeah, we've got that. That's repetition. You've just said what someone else said. Do you want to think about it? Who's that next to you? Oh, is it Jayan? No, it's Bernard. Bernard? Hi, Bernard. What's a code smell for you in Java? Are you much of a Java programmer or are you mainly Haskell?
I'm a read any Java program.
Yes. So Java would be a design smell for you? No. Do you have any smells in code in general? It doesn't have to be Java. You're a tutor, you're marking? Long functions. Yeah. Long methods. That's right. That's a good one. In all languages. Absolutely. What about Thurston? Where's Thurston? Thurston, what's one for you? You relay the answer so we have delegation going on. We've totally encapsulated Thurston. And we've timed out. Okay. Someone else. Yes. Dominic. What's that? Oh, crap names. Now, look, we've got all these grand abstract things here which are really important, but we can't forget the basic things. Crap names are such a problem. The first time I try and debug any code, I just go through renaming everything or ask if I'm with the person who wrote the code saying, well, what does this actually mean? What's it doing? And they say, oh, that's the count of how many feet the person's got. And I say, well, can we change it from yak fat to feet count then? And they go, oh, okay, but yak fat was the name of my dog. Yes.
Comments with like to do or to still
Yes. To do comments. That's scary. That's suggesting the code hasn't had much loving. No one's looked over it. It's just thrown there. In fact, comments themselves are a bit of a smell. We love code that's so small that it doesn't need comments. Whenever there's a comment, it's a smell, but you don't fix that smell by taking the comment away. It's probably better to have it there if something complex is going on. Yeah. There was another one. Yep. Peter.
Yeah.
Yes.
More than one dot, so break them.
Oh, yeah, more than one dot. Though, but it's also not just more than one dot. It's let's phrase it as that way. What was that called? That was the.
I can't remember the name you gave it.
Does anyone remember? The idea that you can't. Yeah, an object should know about as few objects as possible. So it knows about the objects that are passed into it. It knows about the objects it stores itself. It knows what else it knows about itself? No. It's called something like D. It's a D. Demeter's law. Demeter's law or something like that. It's like diameter. That's how I sort of remember it. Yeah, Demeter's law. That's a good one. So I think more than one dot is a really good one because it's a literal smell you can look for in the code and see. And what it's meaning is an object knows too much about other things. More than one dot. Yes?
What about with that if you have a whole lot of dots which let you read it like a sentence? So in Rome you can have like the card at this dynasty is characterized.
No. It's nice to read it as a sentence, so I see what you're saying, but it's unusual for that to be a good design. It's normally every object should just know about itself. So if you need to know about what your children's children are structured like, and then you need to know everyone along the way, what they're structured and what methods they've got and things like that. You're dependent on a whole lot of stuff. And now there's no flexibility. You change anything in that chain and this code is gone. Better if there's a method it can call and someone it's directly related to that solves the problem, and that person looks after knowing the further ones. Yeah. I know it seems convenient. Don't be frightened of method calls. The overhead of a method call is very, very low these days. Yeah.
So my other question is so say you've got like in Roman where you've got various hierarchical structure.
Yes, yes.
You've got cards on a player side, like cards on like dice disc on a game board in a game.
Oh, we talked about that on the forum. Was that you or someone else?
I think it was me.
Yeah, there's a post on the forum about that, and I did post an answer to that.
Do you have like skip classes that it's just like jump all that, or do you have like stacks and stacks of different methods? Or?
So at any given instance, you should know about all the things you need to know about, and the people you know about should either have the information you need or themselves know how to get it. And you shouldn't know how they get it.
Yeah. But does that mean you just have like,
It's very, if you have a whole lot of chaining, like in that forum post that someone was talking about, so I asked my object to pass it on to his object, who pass it on to his object, pass it on to his. It suggested to me that the objects weren't arranged very well, that some important relationships might have been missing. Like if I'm always accessing you and I have to pass through you and you, but actually I never talk to you and you unless I'm accessing him, then probably I need to know about that directly. Yeah. Or there needs to be an object over here that I talk to that looks after that. Yeah. Yeah. Yes?
What if this is something like a getter? So you have a, in Roma, you have a game, which
Yes.
gets the game board, and then
Yes.
it gets the deck.
Yeah, if you have to unpack the whole structure, then this is why I said it's not just one dot. Because you can avoid having one dot by having this iterative, I get one of these and I strip that off, and I get one of these and I strip that off, and I get one of these and I strip that off. But essentially you're needing to know about the structure of a whole lot of objects. So it tends not to be good. Now Java itself does this, okay? When you create a print stream writer or whatever they're called, I can never remember each of them, you build knowing all the other ones. You know, that's a bad example of how to do something in a way, because it means you need to know about this whole long list of stuff. Yeah. So I don't like that. So better to encapsulate if you can. Sometimes you can't escape it, but it's just a smell. Smell means something odd's going on here. This guy needs to know about a lot of other classes to do one simple thing. Why is that? You know, it's like if your mum, if you had to fill in a form at the uni, suppose you want to enroll a subject in a subject. It should be as easy as, I want to enroll in this subject. Can I enroll in the subject? Do I meet the criteria? Yes. I want to do it. Click a button. Yes, I've done it. But suppose the uni was set up so you had to get forms and line up and check and see people and knock on doors of people that weren't there to get them to sign forms that you take to other people who want you to go back to them. That would be a smell that suggests there's too much work to solve this simple task. The uni should organise its procedures differently. Sure, you can do it that way, but can you see it's just not a very good design? And you probably experience that bad design every day at university. Because there are lots of structures we have that are overly complex and overly indirected, and you need to know too much information to be able to do something, and someone not knowing how to do it can often find it hard to do something. But that's not a good design for a program.
Maybe that's because they don't want you to do that.
Maybe that's because they don't want you to do it. But if they don't want you to do it, they should say don't do it. It's not fair if only a class of people can do it because they're persistent, or... Yeah, that's not a good criteria for selecting who can do and can't do things, I reckon. Yeah, maybe it is, but I think there are better and fairer mechanisms. Anyway, but we're drifting off topic. We've got 5 minutes left. Are there any more smells? Come on, you've all got smells. Yes?
When you do have all your variables as private, but you have so many getters that really it's all public.
Oh, okay. You have all your variables as private,
Yes.
but you've got lots of getters, so it's like it's public. Well, so yes and no. I reckon yes. Yes, that is a smell. But I don't think the smell is that you've got lots of getters, because it's still better than making it public, because anyone that gets it has to pass through your method, so you still get to observe what they're doing, so they can't bugger things up without you knowing. I think the problem there is, and it's a really big one, is your class has no existence except as a home for a whole lot of data that people get. Yeah, it's really a struct. It's not an object, it's a struct. It doesn't have any real responsibilities. When that happens, that's a smell, like maybe it has to be like that, but it sounds like you've got a God object, you know, a God global data sitting there. Really, probably you've got to think, who uses this data? Oh, all these classes use this half of the data. All those classes use that half of the data. I'm going to rip this data out of those classes and redistribute it over here, and rip this data out and redistribute it over there. Yeah. You don't want classes to do too much, and you don't want classes to do too little. Either of them are hopeless. Yeah. Oh, it's not easy, is it? Are there any more smells? Yes? Tabs, yeah. I mean, someone that just doesn't lay out their program very nicely is always an alarm to me. When I read it, I just start to think, I just have a loss of faith in the person that's written it. So it's just a mess and it doesn't look nicely laid out. It's hard to understand for me to understand it. I think it must have been hard to understand for them to understand it. And I also think if they loved it and put care into this, how could they have made a monstrosity like this? You know, I think this was just thrown together. You know, maybe they're like me. Whenever I write an essay, it looks like I just vomited on the page and I've scrawled and it looks like I put no thought into it and I've spent all day trying to get some words down on paper, which is very hard for me to do. And someone looking at it could look, this is written by an idiot who couldn't care less. And it prejudices them against me straight away. Well, so I know it's not necessarily a fair prejudice, but it's certainly a smell. It suggests to me that someone hasn't put a lot of thought or care or pride into their code if they haven't laid it out carefully. And because, you know, laying it out carefully reveals mistakes, helps you organise the information, and it's just, you just do it if you're pleased with what you're doing. Yep, all right, they're really good smells. Now, here are some, there are good bad smells. That's right. Here's a list of smells, design smells, not the code smells, but smells in designs, and I've lifted them out of this book. Okay, duplicated code is bad. If it's got duplicated ideas is bad, or even duplicated cut and paste stuff is bad. Sometimes it's okay to have duplicated stuff, but normally not. We talked about one example yesterday, didn't we? Long methods, if your methods are too long, they're doing too much, that's a smell. Conditional complexity. If you've got some sort of if-then thing going on and there's lots of paths and it's very complex. Now in C sometimes we were compelled to do that, but in Java never. And you know we can replace conditionals with polymorphism all the time. You know the thing I was talking about yesterday, that you ask the object to do something and the conditional is really who's the object that you're asking. That's where the variance comes in. So we want to get rid of complexity. We're hoping to have, what's it called, a cyclomatic complexity? Bernard, do you remember? Cyclomatic complexity? What's it, cyclotomic? What's that phrase that measures the number of paths of execution through a program? Cyclomatic? Cyclomatic. Yeah, you want it to be 2 or 3. In C, it's hard to pull that off. In Java, you want it to be 2 or 3. You don't want more than 2 or 3 paths through any method. So you want lots of small methods. So conditional complexity is a smell. Suggests you've got to make some sort of change. Because it's complex. It's just a breeding ground for errors and mistakes. And hard to understand. Alternative classes with different interfaces. So if I've got classes that are very similar to each other, I could almost use them as alternatives for each other. They're doing related things, but their interfaces are very different. That's a smell. And what should I probably... We're not talking about solutions yet. That's a refactoring. That comes next. But let's just jump a peep ahead. What do you reckon you should do if you've got classes, 2 different classes that do similar work, but they've got quite different interfaces, quite different methods? What would you do to fix that problem? It's bad because, yeah, it's got duplication. It's bad because if you change one, you might not want to change the other. It's bad because you've got complexity there you don't need. You should simplify complexity. It's really an example of duplication, isn't it?
Assuming they do the same thing or close to, you
Yes.
could merge it together.
You could merge them together. You could use one instead of the other. If they did related things, then we'd use a design pattern called an adapter, where you'd put a wrap around one of them to make it look like the other. Then you'd change all your calls to that one to be calling the adapted version of it. Yeah. And then you replace the wrapped round one with the other one. Does that make sense? So once you've wrapped something up, you can use it interchangeably with the other one. You can use either of them. So now the 2 classes really now look exactly the same. They're just 2 different implementations of the same interface. And we like that. That's nice. Now we've found the commonality between them and we've explicitly marked it. Feature envy happens when... What do you think feature envy might be? They pick such great names for these smells. What do you think feature envy is? Who's got feature envy? I'm a class, I've got feature envy. What am I doing? Yeah, well, no, I'm just always using your features, man. I like your features. I just really want to have your features. I want to access all your features. I'm just always using his features. I really like his features. I'm just grabbing them, using them all the time.
You're making me feel uncomfortable.
Yeah. I wasn't talking about you. I was talking about... No. Okay. There's no good way out of that, is there? I'm going to make someone uncomfortable. Yeah, okay. So that's an indication that really this object is just fooling around with the other object all the time. Maybe it needs to be merged with the other object. Maybe the parts of the other object it's always fooling around with need to be moved over to this object. Maybe they belong more to this than that. Who knows what's going on? But there's something not right. You haven't allocated responsibilities to classes in the right way if it's not mainly you using your features, but you're more interested in other people's features than your own. Indecent exposure. That's when you, yeah, you're revealing too much stuff. You're not encapsulating. Yeah. Maybe you've got public methods that don't need to be public. Maybe you've got public attributes, of all things. Your large class, your class is too big, that's no good. A lazy class, your class is too small, that's no good. Oddball solution we talked about. Primitive obsession. Primitive obsession is an interesting one. You sort of haven't resigned yourself to the fact you're not using C anymore. Or you've got this vague feeling in the back of your mind that it's better to use primitive types and objects because objects are slow. So instead of using an object to represent a card type, you give everyone a code, a number, an integer. Yeah? That's primitive obsession. You love doing it. It looks fast. The danger is it's very hard to do correct subtyping on it, isn't it? It's very hard to check it's a valid number and it's not a valid number. You can syntactically type something in that's not the right number. You can type something, maybe you've got 20 cards. There's nothing to stop someone typing 21. Yeah? But if it was a class you were using, and I'm either using one of 20 classes, you can't create a class that doesn't exist. Yeah. So we want to sort of move away from having primitives. We want to use objects wherever possible, and then there's costs associated with that, so we have to deal with that. So there are design patterns to let us use more objects but to reduce the cost, such as flyweight and things like that we'll look at. Solution sprawl, switch state. Okay, look, these are all just a whole lot of them. I guess we're not going to talk on them all, but if switch statements are a smell, yeah, that's right. So, because when I see switch statements, I really want to see some sort of polymorphism going on, don't I? I want you to be getting patterns. I want you to be getting objects to deal with this, different objects implementing the same interface or different instances. And that's where I want the logic to be, in the object selection. You should get this book. You don't need it for the course. You should get it. It's an awesome book to have. You should get design patterns, and you should also get Martin Fowler's refactoring book. Okay, now I think that's nearly all. No, two things to say, then we're done. One is there's a site called C2. Now this is, pretty sure it's Ward Cunningham's site actually. Does anyone know? Pretty sure he's certainly a contributor there. I think he might even own the whole domain. This is a great OO design site. If you go to C2, it's got definitions of everything and all sorts of thoughts about things, and a lot of people debating stuff. And there's really interesting arguments going on there, and seriously good people, as well as opinionated ignorant people, but seriously good people. If you go to C2, there's a list of smells at C2. So you should certainly fool around the C2 site. Whenever I talk about something that doesn't make sense, or I was insufficiently clear, or I was incorrect, check it out in C2. And in C2, they're going to talk about code smells. Oh, they talk about code considered harmful, and all these things. And you click on any of these, and you find out about lots of smells. Smell, 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 smell. And the last thing I wanted to say, it's only going to take me a second to say it. Here's some empirical evidence for the code smell concept. There's a Stanford paper where the author, a lot of people now do these metrics where they scan through code and then count metrics on the code, and normally I'm a bit skeptical about that sort of thing, but it's interesting. But some people just like converting everything to numbers. But they found this very interesting thing, that code that had code smells in it was highly correlated to code that had mistakes in it. So they find that not only the authors use code scanners to look for redundant operations. So when someone does an assignment that doesn't do any work, when they have duplicated conditions, so their logic isn't quite right. This is the sort of stuff Richard was talking about people that write games that just don't play around with games very much. So they look for lines of code that really just weren't achieving anything. And they found that the presence of redundant operations in a source file is a good predictor of other hard errors in the same file, of actual errors in the file. In other words, the people that write code that have these little crap things in it, that in and of themselves aren't bad. I mean, you can do an assignment that doesn't do anything and it doesn't hurt the program. But the people that write programs that have these irrelevant assignments in them tend to also write programs that have mistakes in them. And this was exciting to me because it reminded me of a story I just heard very recently from some penetration testers who were telling me of some work they were doing with the Unix source code, the Linux source code. They were going through it, not Linux, they were just looking through open source. IBM, and I can't remember what actual application it was, but it was an IBM application. And they found some places where the programmers had done these dumb things that they were looking for. And they said, unfortunately, there were like 20 times they found this particular mistake, irrelevant mistake, in a piece of code, but none of the times could it be exploited. None of the times could you do anything bad with it. But then they had this really clever idea. And they scrolled up and they looked at the names of the programmers who were working on this code that had these small, stupid mistakes in it. And then they just gripped the code base for code contributions, updates and commits made by these programmers. And they found a whole lot of exploits really quickly. And they said, these people don't know how famous they are, but once you find someone who's a bad programmer, it's really worth scanning for their code, because correlated with that is a whole lot of serious mistakes as well. So I guess that was an amusing story and it made me laugh when they told me. But it sort of reinforces what I think, which is you should do a good job. You should do a good workman-like job, because if you're careless about the small things, it's either indicative of something, there's some other problem, or it just means you're careless and possibly you'll be careless about the big things too. Okay, so we've talked about code smells, and next week we're going to start to look at how we fix them up. Don't forget your assignment. Your work for next week is a simple task, which is just some simple refactoring, removing duplication. Okay, have a nice weekend.